Welcome viewers to the SD online classes. This is the ninth lecture in this particular chapter. This chapter is chapter 2 of class 10 MBSc Physics, the human eye and the colorful world. Page number in your textbook of MBSc will be 57. Okay, what you see here, dispersion of white light. In the previous lecture we have done prism and how the light gets bent through the prism. That is of course the refraction, and now this time dispersion of white light we want to study. Before studying that, we have to know one small thing, that in 1665 Isaac Newton, who is a scientist, he found that light is a mixture of 7 colors. There are 7 different colors, but we see white light, okay, but inside that light there are 7 different colors, and that prism which we have studied in the previous class is the tool, is the thing which can make white light into 7 different colors. Okay, so that is why we were studying that and now we are studying this. Okay, so what is the dispersion is the next topic. What is dispersion of light? We have to know in 1665 he was the one who said light has 7 colors. How to see these 7 colors is the next one. Now let us look at the picture and you will understand. This is the prism. Okay, this triangle is the prism. Okay, and after that this is the light coming. This is the light. This upper one is not the light, this one is the light. Okay, this light coming here, white light, and then as it enters inside the prism, what happens? It splits into 7 colors, 1 2 3 4 5 6 7, and then when it comes out totally you will see red color, orange color, yellow color, green color, blue color, indigo color and violet color. The one which is bending maximum, see, this is the main path. From there, the one which is maximum bent, okay, suppose this is the main light going here, and which is going the maximum bend, that is violet. Okay, that is why we write this as most bending. Bending means changing direction, which has bending means this one, isn't it? The light is going and which is bending is this one, right? Most bending is violet, and least bending almost straight, slightly bending. See, this is one, this is called least bending, very little bending. Least bending is red, more bending is violet. Now depending of these characteristics, many things are explained in the physical situation. Okay, why red color is used, why violet color is used, why the sky is red, sometimes it is blue. All these are things you can explain with these things. Okay, so it is very interesting thing. So now we'll write what is the dispersion itself called. Depending on this, what is dispersion? When the white light splits into 7 colors, that is called dispersion. We'll write in proper English. Let us see how. Now let us try to understand what is this. Okay, the phenomenon means whole this process, splitting, coming out, everything is called that full event is called phenomenon. This phenomenon of splitting one has become many, that is called splitting. Okay, it was one, the light was one, it became many, that is called splitting. Splitting up of white light, this white light into what happened? Its components are this red, blue, yellow, orange, all these component colors. When it passes through a glass prism, whenever this glass prism and white light passing through it and getting into 7 different colors, that process is called dispersion of light. Very simple. Remember, it is not refraction. Okay, you have to say it separately. Dispersion you have to understand separately. Dispersion is the white light becoming 7 different colors. It's called dispersion of light. Okay, so you have to understand that here we have seen white light is actually 7 different colors in it, but when it is mixed together you will see only one white light. Okay, when they are passed through a glass prism, you will see 7 different colors. Colors are also, in scientific language, colors are wavelengths. Okay, why we see red, why we say violet is because red is the part which has high wavelength, violet is the path which has low wavelength. How to write them? So we will write them as color and here wavelength. What is wavelength? I will tell you separately. Color and wavelength is there is some difference. Okay, what is wavelength? Separately, let's try to explain what is wavelength. Suppose there is a wave. This is wave. Okay, you have seen waves in the water also. If you throw one stone in the water, it will become like this, isn't it? That is called wave. So this wave starting from here and exactly reaching here, same position, this is called wavelength. Now for some movement, this wavelength is small, for some it is very big, like this is the big wavelength. Understand? One wavelength is also very big, but this wavelength is very small. Can you see? This wavelength is very small, from here to here only. Some wavelengths are small. So for the red, the wavelength is high. For the indigo, the violet, it is less. Okay, it's less, slightly more, more, and like this more. It will go more, less, and less, like this. So that is the difference between them. So we will write the minimum is violet, 400 nanometer. Nanometer is a very small unit. Okay, 10 to power minus 9 meter, very small. Even the biggest also, the 650 red is also very small. Red is 650 nanometer to 700 nanometer. Violet, VIBGYO. Understand all the colors: indigo, blue, green, yellow, orange, red. VIBGYOR. Okay, I'll not write the full thing, you can fill up at your own. 445, see, increasing, 475 nanometer, 510 nanometer, 570 nanometer, 590 nanometer, and then 650. So this is the reason why they are seen separately. Okay, so this is the wavelength of the color. Red color is more, violet color is least. Okay, so the deviation of the yellow color is taken as the mean deviation. Why? Because it is at the middle. We believe that this is the mean. This is why when you are doing a simple experiment and passing the glass prism, light through the glass prism, then we don't used to take this one or this one. We believe that it is going from here. That is the one which will represent red also, violet also. Okay, so that is the mean color. Okay, now there are two more things. The one we have already done is the prism is divided. The prism has made the white light into 7 different colors. Fine. Now whether the prism is doing some magic or what, that Newton's experiment will tell you. Okay, how? Now what he did is very easy. What he did is he made one prism here. Okay, and then this is the experiment not done by Isaac Newton. Okay, this is the experiment by another scientist who is Newton. Okay, same Newton, the one who has given you Newton's law of motion and all. Okay, so now these are the 7 colors you already know. I'll not make all. This is the red, this is the violet, and we take only the middle one. Somewhere here it is the yellow. Okay, and then this is the screen where the spectrum is received here, red, yellow, all this. Okay, so top is red, bottom is violet, this is red, this is violet. Okay, and this is the middle one, yellow. There are other also, green, indigo, all are also there, but that is not important in this experiment. So what he did is he made a hole here, not here, this side is all cover, here a small hole he made, and he allowed only the yellow color to come out. Okay, only the yellow color to come out. And what he did now is he putting another prism here like this. Okay, now this will go from this prism, this will go from here, okay, another prism, and what will happen to this is it will go down and further down, just like normal light, yellow light is bending, and here he found this yellow, here also it is yellow color. In the screen, this is screen, this is screen. Here he found it is yellow in color. That means what? That means the prism has not done anything. This prism also has not done anything. The light has that property. Light has inside all the colors, and only the yellow color has come out from here. And if the prism was doing something, it would have made again 7 different color, but it was not doing. This time only the yellow color given, yellow color coming out. Here white light given, white light was given, you got 7 colors. Okay, here it is dispersion happening, and here what it did, here it was refraction. Okay, refraction, and then you get again the same color, yellow color. So that means this proves that light itself has this property, 7 different colors inside. Okay, this is one experiment of Newton. Another experiment is also there which Newton has done, which is that he made 2 prisms sit together, and here he verified all the prism will do the same or not. He made one prism here and another prism here. I may make mistake in my diagrams, but it is there in your textbook also, you can see very nicely. Suppose this is the white light coming here, and this is the red, this is the red color, and I should draw outside red color in that, and then it will go here, it will go somewhere here. Okay, this was red, this was violet, and as they enter here, okay, as they enter here, what had happened, they again combine themselves into one color. Sure, I made some mistake, I'll correct it, no problem. Like this they will, so I have corrected them. This is the light. You should have all the 7 colors here, 1 2 3 4, whatever possible you draw it, 5, maybe this is the 6th and 7. Okay, so like this you can draw and make them. And here they go like this. The inside one is not very important, even if you don't draw also, you have to write the N colors, red and violet colors properly, and it will be understood. Okay, the concept is that the prism is the important thing. The prism is doing everything. Okay, the prism is making the white light into breaking into some 7 different colors. Okay, so light actually has those 7 colors in it, and one prism has done, the other prism has undone it, opposite. You understand? It has done, this prism is A, this prism is B. Here it is red color on the top, violet color in the, and when it comes out from here, when it is coming out from here, it is coming out again white light. Here it was white light. Okay, so this was done by Newton for, this is called recombining the dispersion world. So this proves that light has 7 different colors in it. This proves that what he also showed that the second prism identical. So with this glass, what is called is the second prism recombining to form again the white light into 7 different colors. This first one is getting you. So this way he has shown 2 experiments on the white light with dispersion from the prism. Okay, these are often asked in the exam also. This is all in this prism. Thank you.